Okay, so I want to find numbers that make it true. You told me that 2 makes it true. What if I couldn't guess the answer? What if it were 2.15? I've never guessed that. So what I want to do is find a way to find numbers that make that sentence true. So I want to isolate the x, and it's the reverse of order of operations. We are going to undo first the adding, subtracting, and then we'll undo the multiplying, dividing. And you're right, 2 does make that true, because if I substitute 2 in there, I do get a true statement. But let's pretend I'm really tired. I don't want to think, because, that requires more thinking. This is easy. This is a process. So I want to get 2x all by itself. What do I have to do to get 2x alone? Subtract 1. Here's where I start, and I've been doing this for a long time. Here's where I start actually showing my work. And there's your equal sign. And you have to be equal. Mickey and Minnie, well, I'm never equal. I get them little pepperoni treats. She gets the whole thing, and he gets just a little dab because he's so overweight. Well, I found out why today. He's eating the big dog's food. I go over there and go, Mickey, what are you doing? You already had your food. I don't know. I got to get a new plan. He's 13 pounds. He's a Chihuahua. Chihuahuas are supposed to be like 4. He's a big guy. So now we'll add that. I always add. So we got to keep things equal. So that's 4 equals 2x. And I hope by inspection you can see what to do with that. But let's pretend we're really tired. And I want to undo that multiplying by 2, so we will divide by 2. So if I keep everything lined up and organized, those of you who are not organized, it's going to be a problem later on in math. This is 2, and this is equal to 1x or just x. You can always check it. So that's a 2-step equation. So you undo adding, subtracting first, multiplying, dividing. Now I'm going to go ahead and get into what we're going to be doing tomorrow a little bit. This is with fractions. I know how much you hate fractions. Fractions are fun. Fractions are our friends. You don't like them. So what I'm going to do, it's not really cheat, but I'm going to do a little process. I'm going to do what I call clearing fractions. And by the way, when I go back to this equation, it's obvious 2 makes this sentence true. Chances are 2 makes that sentence true. They are 2 different sentences. If you look at them carefully, they are not alike. But they have the same candidates for solutions. I don't want to use answers because you know what? What's the answer to 2 plus 3? It's 5. 5 is not a solution. There's no sentence. That's a math phrase. We can simplify it. We cannot solve it. And some of you are thinking, why does she care about that? It makes a difference when you get into higher level math. If you don't know what these words mean, you don't know what to do. So we're going to work on it now. So what I'm going to do here is clear out my fractions. I could undo by adding 12 to both sides first and then multiplying. I could do that. Or I could say, I don't like dividing by 4. So instead of dividing by 4, guess what we're going to do? We're going to multiply everything by 4. I'm going to multiply this term by 4, this term by 4, and this term by 4. Those of you who had me last year, which is 1, you'll see that's the way I did my fraction problems. I got rid of them. I call it eliminate fractions. What is this going to give me? The numbers get bigger, but I don't care. Negative 48, right? What happens to the 4s here? They cancel out. What's 4 divided by 4? 1. I don't want that 1/4 there. I don't like that, so that cancels. And this is equal, plus. J is still there, Miss J. Equals what? 36. Now the numbers are a little bit bigger, so I'm not going to guess and check as easily. So I'm going to show my work, and I am tired today. So I am going to get J all by itself by getting rid of a negative 48. What do I have to do that? Add 48. And you know where my biggest problem is with adding numbers? Doing the carry. just have an issue with that. That's 0. Do you agree? Okay, you're hopefully going to do it faster than this. I'm just going through the process here. And now when I add 6 and 8. I'm not going to do a calculator because I don't need one. But if you need one, use one. What's 6 and 8? Do you have any golfers here? You got to be able to add these things. 14, right? Well, it's not a 1. It's 10 because you're going to put it over here in this place. But numerically, you're going to add 1 and 3 and get 4, and 4 is 8. And can I check it? Is that right? I want to go back to the original sentence because if that doesn't work in the original sentence, I did something wrong. And it's 84 divided by 4. Is that equal to 9? Well, I can do 84 divided by 4 in my head because it divides nicely. 4 into 8 goes twice. 4 into 4 goes once. Is that equal to 9? Yeah. Check it with a calculator if you want. I don't care. But I don't check the one that I transformed. I changed this equation into this one without any fractions. I like that. Because I don't like fractions either. I can do them. They just slow me down. So I got rid of the fractions. I eliminated the fractions. And then I just solved because I know how to do that. That's easy. Compared to the other thing, it was a lot easier. But the problem is I might have made a mistake going from here to here. So I better check in the original just to make sure I didn't make that mistake. It doesn't look like I did because it works. And again, I want to clear out those fractions. Let me rewrite this a little bit differently. I don't know why they use J's. I don't particularly care for them. Let's write that as 9. Let's write that as a fraction. What's in the denominator? 9 divided by what is equal to 9? 1. I love 1. That's a special number. And now we have a proportion. You can either think of clearing fractions by multiplying by 4 on both sides, or you can think of as cross-multiplying. The product of the extremes, the product of the outer ones, this one times 1, has to equal the product of the means, 4 times 9. The reason why I don't like using cross-multiplication is that expression. It's not wrong, but the problem is you tend to get that mixed up with multiplying fractions. Not the same thing. Well, I look at my denominators, and I don't want those denominators there. What can I multiply both sides by? Now, I could go bigger than what I'm going to choose. But what does 4 divide into? Not what goes into 4. What does 4 go into? 16. Let's do 16. There's a smaller number there if I want. Okay? What happens here when I do this? Does 4 go into 16? How many times? 4. So I get 4 times negative 12 plus j. This little bar is called a vinculum, which is like a parenthesis, but you never heard that word before. And 9 times 16. Anybody know what 9 times 16 is? You guys have calculators. 144. And then you could distribute, which I haven't gotten to yet. Could you think of a smaller number to clear that out, which I don't have to do the arithmetic, isn't so bad. 16 is nothing wrong with 16. It's wonderful. However, there's a smaller number that 4 goes into. Smaller yet. 4. I want the smallest one. But, you know, it doesn't matter. As long as I pick any multiple of 4, I'm okay. I could do that. I just haven't gotten to distributive property. So I was kind of wanted to put that off for a second. And now what happens to the 4s? Which is nice because it's convenient. These do what? They cancel out. And what's 1 times anything? The same number back. What's 0 times anything? 0. My favorite numbers because it make life so easy. So this is negative 12 plus something, j, is equal to 36. And again, I'm probably not going to guess correctly, so I will solve for j. And what do I have to add to both sides? Because now this is like what we did yesterday. Add what? 12. So I won't be here tomorrow morning, but if you need extra help on any of this, come in Friday morning. I plan on seeing you. And you can come at 7:30. You don't have to come at 7:15. Okay, does that give you 0? Yeah. What's 36 and 12? What's 2 and 6? Well, I'm going to do business with you guys. What's 2 plus 6? 8. What's 3 plus 1? 4. 48. Now, does that work? I don't know. I'm going to go back to the original because if I go to the one where I changed it, I might have made a mistake. So it's negative 12. What did I just say it was? 48 plus 48 divided by 4. Is that equal to 9? And you could do a guess and check, but really, would you guess 48? It's not exactly small. Now, this is a vinculum. This little bar says, add what's in the numerator. What is that? What's a 48 take away 12? And if you have to do a piece of scratch paper or you get your calculator out, I don't care. What's 8 take away 2? 6. 4 take away 1 is 3. 36 over 4, is that equal to 9? Yeah. Can you punch it in on your calculator and test it out? Yes. Be careful with your order of operations. Just because you have a calculator doesn't mean you're going to get the right answer. Okay, these are just 2 steps. They're a little more complicated than yesterday. Now, this one is like, it's still a 2-step. Looks like it's like what we did yesterday, but it's harder. Yeah, you got lots of room to draw. Again, I will undo adding, subtracting. I want x all by itself. And if you have problems with these, then I really do want you to come in and get some extra practice with this, because it'll come back and haunt you. And if you're thinking of college, you've got to take the ACT. Which is far more complicated questions than this. I want x by itself. So forget all of that. I want to get rid of what number, the 13 or the 8? Which one's tagging along with x? 13. How do I get rid of that positive 13? Add a negative 13. You can say subtract if you want, but I think you get confused. Now, I have to put the negative 13 on the other side of the equation. I can't put it under the x because that wouldn't be right. Now you got to be really careful. What's still left? I know it's picky. It's not just x. What kind of an x is here? Negative. And 8 take away 13. It's 8 degrees and it drops 13 degrees. It will be that cold this winter. How cold will it be? 5 below. Now there's still a number with x. It's kind of hidden, but it's there. And if you want me to write it in, there's a negative 1 there. I don't want negative 1. I want a positive 1. So I'm going to divide, or it can multiply, it doesn't matter. By what? I want to get rid of negative 1, so I'll put what here? Negative 1. So x, because that gives me positive on the left side, and gives me a positive 5 on the right side. But there's another way to think about it. I kind of like this other way, of thinking. Copy that one. This says, if you want to do it by inspection, it says the opposite of what number is negative 5. The opposite of what number is a negative 5? What's the only number that makes that work? 5. The opposite of a positive 5 is a negative 5. You got to think a little bit more, but it's kind of, this is a process, this is memorization, this is thinking. This says the opposite of whatever I put in there. Remember what we're doing. We're solving. We're trying to find any number that makes it true. Opposite of what number will equal a negative 5? What if I had this? The opposite of what number is 3? What's the only number that goes in there? Opposite of what number is a positive 3? There's what I want. Opposite of what? Negative 3 is a positive 3. Those are opposites. They undo each other, adding opposites. Okay, so I'm making you think a little bit. Let's see what I mean by solve. I just made this an easier problem. Instead of dividing by negative 1, I can do that. That's work. Or I can think a little bit and be clever. I like to be clever. Okay, I don't like that 4 there. What should we do to both sides? Multiply by 4. You could do 8. You could do 16. You could do 64. Anything 4 divides into. This is actually easier than ones we've done. Notice my use of parentheses. I don't like the dots because the dots get confused with decimals. And if you had parentheses from the time you're this big, it wouldn't be an issue at all. But unfortunately, I need a new color. Oh, let's try that one. What happens to the 4s? 1's in the numerator, 1's in the denominator. What's this equal to? Just 1. No, because 1's in the top and 1's in the bottom. 4 goes into 4 once, 4 goes into 4 once. So I'm left with, on the left side, 3m equals, and what's negative 9 times 4? Negative 36. Can you tell me what works, or do you want to go through the process? The process is to do what? Opposite of multiplying by 3 is dividing by 3. Everybody should have these written down. Should hopefully be ahead of me. That's the best case scenario. So m equals, what's 36 divided by 3? 12. And this is negative, that's positive, so this is negative. If you need help with sign numbers, I can find worksheets and activities for you to do that. Let's use a calculator. And right now, since you don't have your iPads, you can use your phones. I don't care. Okay. I don't like the expression getting rid of, although we'll say it. We are going to eliminate the parentheses. One class, years and years ago when I first started teaching, I think I said, get rid of the parentheses. You know what they did? They took their pencil out, and they took their eraser, and they erased the parentheses. I go, can't do that. Those parentheses mean something. This is the distributive property. And if you'll notice, I'm kind of particular about this. It's the distributive property of, when you do distributive property, there's 2 operations involved. You may think you know distributive property, so pay really close attention. Distributive property does not hold in all situations, and it will come back and haunt you later on, even in this class. So we got to get it right. That's not good enough. We're going to distribute this multiplication symbol over that subtraction symbol. So we're going to distribute multiplication or division. Let me put that in parentheses. Over addition. Or subtraction. And I know it's a mouthful to say. DPMA. My second year of teaching, I was quickly corrected on how I taught it. I know many teachers don't teach it that way. Like I said, I work for the College Board. I teach teachers. I know they don't do that. I said, you have to do that. Because when I have exponents, they don't distribute. So guess what? You got a problem. Not everything distributes. We think it does. Does everything commute? Remember, I don't know if you know this. Commutative property. 2 plus 3 is the same as 3 plus 2. It doesn't matter the order in which you add. Just change it to subtraction. 2 minus 3, is that the same as 3 minus 2? We have $2, and I want to give you 3. Sorry, I have $2. I want to give you 3. I'm not going to be able to do that, am I? I'm short $1. But if I have $3 and want to give you 2, I can do that. So these are not the same. This is not commutative. You cannot just change the order in which you add or subtract at will. You can do it for adding. You can do it for multiplying. You cannot do it for division. It's 4 divided by the 2, the same as 2 divided by 4. I have 4 pies. We're going to divide it half. You get 2, I get 2. I have 2 pies. Now we're going to divide it among 4 people. You're not going to get half a pie. So it is important to talk about distributive property multiplication over addition. And if you remember, what I do is I like to call these like mailboxes. There's 2 mailboxes here, and these are the flyers I'm going to give out, and everybody in the post office gets a flyer. So you distribute. It's A times B plus, and then it's A times C. And I like to draw the little arrows. And we're going to key off of that again later on this year. Distributive property. What I like about math is no matter how you do it, it has to be true. Let's do this the old-fashioned way. What's 3 plus 5? 8. What's 2 times 8? 16. Some of you don't like to distribute. You don't want to give every mailbox here a flyer. Well, I'm the advertiser, and I want every mailbox to have that flyer. Because I might miss somebody. Somebody might buy something from me. So if you distribute, you go 2 times 3. And what if I switch 5 and 8? Because I can anyway. 2 times 3 and 2 times 5. They're not the same things. And 2 times 5. So everybody's got to get multiplied by 2. What do I get here? 6 plus 2 times 5 is 10. Gives me 16. That's the thing you don't like about math. You can't fudge it. No matter how you do the problem, if you don't come up with the same answer, one of the ways you did it was wrong, which makes me think of my mother and her checkbook, because she used the calculator to balance the checkbook. And she did it by hand. She got the same answer, and unfortunately the answer was wrong. So that's still not foolproof. But you better get the same answer. If you don't get the same answer, then for sure something's wrong. But even if you do get the same answer, doesn't mean you're doing it right. Okay, so that's what we're going to do. We're going to distribute here, and I'm going to recopy that because I don't have space. So it's negative 2 times b minus 4. Now, we might have some issues. These are still nice numbers. But if you get a fraction, don't be afraid of it. It's okay. We still may have some issues with how to do this. If you have problems, did you know that subtracting is the same as adding? The opposite. In math, everything comes in pairs. Okay, girls, it's important. Everything comes in pairs. Because where do I see the mistakes? All the way through calculus, I see the mistakes. You forget to distribute the negative sign. What's that first one going to give us? By the way, I'm not going to guess this one. Not easily. I know it's a nice number. This is negative 2b. Now, don't forget to distribute the negatives. This is where I see the mistakes. All the way in calculus. So this is important. What's a negative 2 times a negative 4? The negative gets distributed. 8 plus 8. Where do you think the mistakes are? I see negative 8 all the time. All the time. It gets even worse if I just put a negative sign out in front there. Way worse. I can give you some examples right out of calculus where they do it wrong. Okay, now we know how to do this. I've made it a hard problem, an easier problem. What should we do next? We want to get b by itself, so what are we going to do? Minus 8, minus 8. Use a calculator if you're going to get the numbers wrong. Because I don't want my bridge to collapse. I don't want it to be wrong because of arithmetic. That's silly. So it's negative 2b. What's this give us? 0. What's 12 take away 8? 4. And now maybe you can do this by inspection, but let's divide by negative 2 because I want to make sure I get it right. Yep, so b equals negative 2. There you go. I'm giving you more detail than you want to hear. But then you have to ask yourself, why are you in this class and not in geometry? You need those details. You need them. Once you get them, I'm going to open a lot of doors for you. You're going to be able to do a lot of math you never thought you could do. But you've got to get the vocabulary down. This distributive property is not good enough without this and that, because not everything distributes. I used to think that was the case until I got into linear algebra, and then I found out, oh, there are a lot of things that don't work. And that's what mathematics is all about. Okay, why don't you guys try that? That one's easier because there are no negatives. Try that, see what you get. You're going to distribute. And I think if that's not the last answer, it's probably pretty darn close. The last question. That's all old. I will put my old things. Well, some will be in here, some will be in my other room. So if you don't have a pencil, I'll give you a pencil. But write it out. Somebody want to come up and do it? Come on up. I'll get you more involved. I got to get to know you a little bit better. The board is pretty well aligned, so you should be okay. Oh yeah, there's some really tough ones here. Next one's really tough. And you may have some questions even on the first assignment. And if you stand to the side, you'll find out you're not in the way of the light. There you go. Okay, did everybody get that? The homework's harder. It's okay, stand on the other side. I do both. A couple years ago, I broke my arm. I had to be like, I'm left-handed. These are going to take you longer, but hopefully we have a little more time. Not a lot. You should have a little homework with this. I don't expect you're going to get this done. And you may have way more questions on this one than you did on last night's. And you can check with a calculator. Who did I miss? I always miss somebody. I always miss somebody. There you go. And then we're going to do one more, and then we may go right into the to your worksheet and try a couple of those too, because they're not so easy. So answer is k equal to -1. Let me check. 3, -1 plus 8, because that was easier than following through on his work, actually. His work is very nicely done, by the way. So 3 times 7 equals 21. Yep, that's true. Questions on that? Did you do the 3 times the 8? So we went, this is a quantum leap from yesterday. We went from just 1 step to 2 steps with distributive property. Tomorrow will be really much more of the same. So you're going to get more practice tomorrow and the next day. Is anybody brave enough to try that one? That one's hard. You want to come up? Come on up. I like to have you guys come up and do problems. Now, we didn't do one like this. What should you do next? Before you try to solve. You can solve, it's just harder. Shouldn't you simplify it? She's simplifying it. She's saying, well, why don't I just do this? Is this a times here? Times a -1? Plus a -3x. Careful. That's, oh, never mind. I didn't see the plus. There you go. My mistake. I have weird convex. If you knew what they were like, you'd understand. And all of you are at different levels, so you just got to bear with this. They're a little redundant. Oh, no, you're okay. Never mind. X equals -1. Does it work? How do you know? By the way, if you do this, you can just do this. So 15. You can use your hands. I know you, but -1 minus 1 plus 9. Order of operations says that's -3 times a -2 plus 9, which is 6 plus 9, which is 15. Can you guess and check on that one? Not so easily. I don't think you can do it easily. Let's see. Okay, that's it. So let's try a couple of these problems together. Why do I have that in there twice? I don't know. I didn't do it. Let's try number 1, because it's been a while now since I talked about a problem like this. Now, some of you are saying, why can't I just subtract by 2 first and then worry about the 4? Yes, you can. But when they get complicated, I really like to eliminate my fractions first. So what are you going to do with that one? I mean, you can subtract 2 first, but couldn't you just multiply by 4? Yes? No? Okay, I have a little stack here. If you're ever absent, everything's online, but it's also right in here. Why do I have so many? Oh. And I'll have some in my other classroom as well. Anybody want to try that? With my method? Multiply by what? The same thing you can do with number 2. Multiply by what? I don't like what number here? I have nice denominators of 1. What number is not nice? 4. I don't like 4. So if I do 4 here, 4 here, it's why I choose it this way, because what will happen to the 4s? Take away. I'd rather do multiplication. What's 4 times 6? 24. Now this leaves me a plus 8. Is that an easy problem now, or is that a hard problem? That's easy. What's 8? A. Can't tell me what A is? I think I just dropped. Schedule. 16. Yeah. Using a calculator is just fine. You may have to use your phones until we get our iPads. So subtract 8, subtract 8, A equals 16. Try the next one. Oh, no, I don't have one in front of me. Again, what are you going to multiply by? Like I said, you don't have to do it this way. But when you get to number 6 and 7, I think you're going to want to. What should you do on number 2? Anybody want to come up and try this? Don't all jump at once. Multiply by what? What can I do? I don't want this guy. I don't like that one. So let's multiply by 4. I really need those parentheses, especially when you're talking about negative numbers. Otherwise, it gets really confusing. What's this going to give me? Negative, no, times. 4 times 6, 24. Whoops, there's no equal signs there. Oopsie. Plus, what happens to 4s here? They go away. They cancel. They divide. They give me 1 because it's 4x divided by 4. That's why I chose to do what I did. I could multiply by 5 if I want, but then it's not going to be nice. I'm still going to have fractions, and I don't like those. So I'm left with an x equals, multiply. 5 times 4 is 20, and it's negative. Can you just look at that and tell me what x is going to be? What kind of 4? Negative 4. Guess and check will work. Otherwise, you can add 24 to both sides. So x equals 4. Let's jump to number 6, because I know you know how to do that other one. Let me get used to my setup here. So I know you know how to do 3, 4, 5 is very similar. What will I multiply by on 5? 20. So number 6 is similar, but it looks harder. What number do I want to get rid of? I want you to practice this. It may be hard at first, but practice it. What number do you want to get rid of? What number don't I like? I don't like fractions, so I'm going to get rid of them. I'm going to eliminate fractions by clearing them out. I'm going to multiply by 6. Any multiple of 6 will work. The smallest multiple is the easiest. And when we get to more equations with more fractions, you're going to realize you want to do this. So let's do this with the easy stuff. There we go. And so this is negative 6, because I'm multiplying those. What happens to these 6's? Because I chose it that way. Boom, gone. 5 plus x. Now, that's an easy problem. However, it's easy to make a mistake. Subtract 5 It's not going to be negative 1. It's not going to be positive 1. What's x going to be? Negative 11. You know on your test next week, you know if you did it right or wrong. You just put it back in there and see if it works. So if I do that, and I put in negative 1, is that equal to 5 plus a negative 11 over 6? Is negative 1 equal to negative 6 over 6? I hope the answer is an easy yes, because it is. Now, what clock works? What clock is correct? I don't know. So try a couple of those. I can put answers up. And we still have, a good 6 minutes. I can work with you or let you do that, and I can also pull up the answers. So why don't I pull up the answers so you can check? This should be on wheels.